All right. Hello. Hello, hello.
Hey,
Welcome.
do you hear me well?
Yeah, hear you good. Thanks for taking the time and being here today. That's really
Yeah,
nice. So
happy to see you.
we haven't had time to talk actually, but I have been following you for a long time. I know that you have been building on the IC for, I think it's been 2 years now, maybe a little bit more.
Yeah,
So we are at Motoko Bootcamp. We have some students here that are learning Motoko. And so I just wanted to have a chat with you because I think it's great if you can present what you've been doing. So I have a few
yeah.
questions ready for you, and I'm guessing that you probably
Go.
have a lot of things that
Yeah.
you can show us. Maybe before that, a quick introduction on
Okay.
you
I
and your
can
background.
introduce myself. So I'm Veselin, from the founder of Neutrinit DAO, which is now an SNS, and I've been working in the online education sector before that, having my own company. I've been developing and being entrepreneur at the same time for the last 25 years, probably around there. So I love the IC, and I said, okay, I stopped everything else and came 2 years ago. I think it was the first public hackathon. Uh,
Supernova.
yeah, it was the first, and I participated with NFT Anvil. I think I can show you everything like a developer journey, and during what I'm showing, I can also show little snippets of code and things like that, which are useful.
Good, yeah, let's do that. Do you want to share your screen? I
Yeah,
should be able to do it now.
yeah. What were the other questions?
Well, I have a few questions like what sold you on the IC? Was it like immediate immediate realization that I want to be building on the IC, this is like a place for entrepreneurs? Or is there like
Yeah.
a specific moment where you
So
did?
I've researched 2 years ago. I made an online course for beginners for crypto, and I started with Bitcoin, like explaining how the hashing function works and encryptions work, public keys, private keys, and things like that. And I was checking out different blockchains. I checked Ethereum, Cosmos, and the Internet Computer. And the way I checked them, I went through their CDKs and a little bit through the documentation, made some examples, tried to run them, and I loved how the IC was working. So that was what I would say was Web3 for me.
Yeah,
because
when you
because I want to build websites, which web apps, uh, and either they're going to be on chain, and the other systems didn't have that. So the web part, which gets served on chain for me, was a deal breaker. Another one was with the Cosmos chain. You need to set up your own network and find your validators, and it was a lot lower level. While on the IC, you just make your contract and it works. Things are simple and you can focus on your business logic. That's why I also picked Motoko, because it was higher level language. I wouldn't have to worry about lower level stuff. I prefer building on that level.
yeah, okay, follow you there. Do you want to
Yep.
showcase all the
Let me.
different tools and projects that you've been building around the okay, Anvil, so I remember this.
Do you see
Yep.
everything? Okay. So yeah. that was our first site. It looked similarly. It just had this when we were part of the hackathon. I think we got third place or something like that. Just a second. So we just start with this little form here where you can upload your image, set your thumbnail, and there are also advanced settings, and experimented with interesting features like different type of verification where you have to upload something on a domain to prove that your NFT is part of the domain. Things like soul-bound NFTs, where they're bound for a duration or things like that, more like what a gaming system would need. Another cool thing which was recently added, like I think a year ago, was these wallet things, which are also working with fungible and non-fungible tokens. These are real transfers. You see, they're updating optimistically state.
Okay, yeah.
Things like that.
I was gonna ask that. So essentially, Anvil is I would say all-in-one NFT platform with also like you have everything, like you have the wallet, the mint, and the marketplace, I guess, as well.
It has a marketplace. Yes, we had a few projects joining. The project is currently paused because if we want to use it again, we'll have to fix the fungible token standard changed, and now there is a non-fungible token standard. So these are just getting.
What is the standard that you use for this one? Is it like a custom?
It uses you see the old legacy addresses, and it uses our standard. So basically, the thing is completely separated from everything else. It's its own standard and cluster and a service where you mint. But if people make services like that where they're creating their, actually everybody currently does that. They create their own standard instead of going to the working groups and working on some standard and then creating an app around it so the whole ecosystem can develop.
Yeah, that's a huge problem, especially for NFTs.
Yeah, and yeah, for everything. So there, yeah. Never mind. Let's move to the. It had its own blockchain things, and we had tools. The idea here is not to have a site, but have tools, and these tools are given to developers to mint. There was a command line to where you just put your JSON and it mints your NFTs, and also React components, which you get this wallet here inside your app, and the mint also React state library, things like that. So it was again a developer tool also. We made this Blast, which is a tool for developers to communicate with the IC. And I like this level of communication, and it's perfect for learning how the IC works. If developers start using libraries right away from like ICJS that the library has its own interface. It's not the IC interface. So it's like translating your calls. And this way of working with canisters, like you're just specifying the ID, it automatically gets the idea of the interface, and then you can start calling it. It worked great for us. And it is still one of our most used tools by us, and probably few.
So it's not using
not very many.
It's using, so how do you get it's a custom service, like how do you get the interface and everything?
It uses my library, which is IC Plus. Let's see. And anybody there with notes or instructors to use it. I didn't. There are some same about those. I
I don't know if it's on my side or if it's for everyone, but I have some troubles with the sound right now. Same.
Hear me?
It's cutting.
I don't know. Let's wait a little bit.
It's getting better. Yeah, it's getting better.
Okay.
Okay.
Cool. 1, 2, 3.
Yeah, because so we haven't seen it yet, but there is this agent.js library that we use a lot to communicate with the IC, and it takes a lot of decision on how to like communicate with the IC. So you're essentially I've built an alternative to it. If I
No,
understand.
it's not alternative. It's built on top of agent.js. It's like just change. You're using still agent.js, but this library is on top and it's changing things and providing utility. I mean,
Yeah, okay.
It's pretty hard to use for anything except testing and Blast. When you try to use it in a web app, it's hard to use. But I mean, because it's not documented, and I'm still trying to figure out how to do it. But at the end, it's just going to be one file you import, and you have like you're calling login, and it's logged, things like that. And then you have React hooks when you log out.
Okay.
One of my favorite functions is toState, because currently returns you interface principal classes and things like that. And if you just try to JSON them, it's not going to work. Well, here you have from state and toState. And IC Plus website uses it. So you can see if we have optional here, it won't be like some zero .ID. It will be some ID or undefined. And when you call ledger, like ICP ledger, let's see. I'm not sure if I have ICRC ledger here. Let's say, yeah, let's see something fun, Sonic Swap. So one of the first things I did here was go to Sonic, use, this is my other favorite tool, but that is Jorgen's, it's not ours, the IC inspector.
Yeah, the IC inspector is great. Yeah.
Yeah, so I'm going to, so you can see what happens here. We are calling the canister, we are getting the metadata from the canister or using the get candid interface temp hack, which was there before the meta got inside the wasm. And then we are sending, we are not currently converting the DIT to JS because we don't have, we haven't done that. We are calling one of the canisters Motoko Playground uses to convert DIT to JS. You can see what happens
Oh,
here.
it's the Motoko Playground. Okay, yeah, I got it.
Yeah, it converts it to, and then see with this library it shows you what happens. So when you want to integrate some other service, you just go to their site, you open inspector, you use blast, then to try to work it out. And this is pretty much how we made this sonic swap thing, because I don't like using libraries. And sometimes they're not well documented, or just if you're going to use, for example, the Sonic JS library, then you can't make a Motoko canister that uses the same because you don't know what's happening, right? The
Yeah,
library
okay.
is like hiding everything.
Okay, yeah, that's great. Okay.
And that's how I've been using it. So it just goes like you're minting WICP, making a swap, withdrawing, things like that. And you quickly understand what is going on exactly to be able to. It's the same thing with SNSs and everything Infinity has built. So it also has an extension for VS Code. How much time do we have? Do we have 1 hour?
Yeah, we can go the full hour.
So there is a VS extension, internet base. It's called. You can just install it from the extensions, and it does the same thing like the site, but in your VS Code, and it is more powerful because the site can't go, can make coarse calls without you installing plugin.
How do you use Blast the most in your workflow? Like, is it just to interact with canisters?
Yes,
That you don't really know? Yeah.
I use it for my canisters. When I build something, I right away make a blast that starts calling it and interact with it right away. You can see deploy.
Is the candid interface always accessible? Because I know it's in the metadata now, but I know that sometimes it's hard to have it. Like if you go on the dashboard, for example, you don't necessarily have the interface.
You have the dashboard.
Your sound is cutting again. I don't know. Maybe it's the. Yeah, my question was about the interface, like the candid interface, because I remember that in Motoko you always have it, but some canisters like Rust, they don't necessarily expose it.
Yes, but say 9%.
Yeah, I think it's maybe the headphones, I guess.
Do you hear me?
Yeah, it's good now.
I can. Shouldn't be the headphones. So The way I use it is I almost never do the manual did file candid interface to JavaScript or anything. I'm just deploying my Motoko file, and I also never use DFX text candid. I think that it's horrible. I mean, they're going to change it, but I'm just using BLAST. For making calls, DFX is probably something that gets beginners like to hate it.
Yeah, because you have to use the candid format. It's slightly painful.
So you just deploy this canister, and then you can start using it here and test everything. It's almost like a test framework, but I'm also using it for everything, like inspecting and things like that.
Okay.
It also has, let me see if I can turn it on. Another tool like internet base. It comes with the BLAST. So you enter the ID here and go to, for example, list neurons. It is currently tuned to work with our way of doing opts. Let's see, manage neuron. So if I want to make a proposal, I want to, let's say, make proposal.
This is the ledger, ICP ledger canister, right?
No, it is the NNS governance.
Yeah, of course. Yeah, the NNS.
Reward node providers. Let's manage neuron. Anyway, motion proposal, here it is. So I do like await governance, and then I'm clicking here. And it's built my query. So I just have to put the URL here.
Oh yeah, I like the interface on the right, like the graphical interface, because it can be very helpful. Yeah.
You can use it with your local canisters.
Someone is asking, is this open source? I mean, I think it is, right?
Yes, the VS Code extension, yes, it is also open source. Yes, if you can find it in my hundreds of repositories. Okay, anything else about the VS Code extension?
Maybe you can drop a link for the installation.
Okay. Oh, if you want, you can just internet. You can just install it from here. You need to install both of these, and then you select kernel. But actually, what you would want to do is go to this repository here and probably start there. You can also use the extension inside code spaces. Like if you go to the repository with the same name, I'll drop a link later. You'll be able to open it with code spaces. It will have the same VS Code editor and everything in here. And you can test various things and go through the basics, because things have to be learned. But the best way to learn it is to get to this library here and check what it's doing. It doesn't have a lot of things that it's doing. I mean, just few files, and then you'll know what it's doing. So let's move to the next project. This is Neutron. Try to hide this. Neutron, it has a light paper that explains how it's working. But the idea is like you currently have developer controlled canisters, right? And you also have DAO controlled canisters. And if we are not thinking about the LNS, like abstracting it away because it controls everything, we could also have something else, user controlled canisters. But how do we do that? And I mean, the DAO shouldn't be able to control the user controlled canisters because then it would be DAO controlled canisters. And somebody has to allow users to install canisters somehow. And these users somehow have to install things inside their canister. Where do these things come from? Does it make sense so far?
Yeah, it makes sense totally. I have a lot of questions coming up. So
Okay.
let's say who is going to, like, let's take the example of OpenChat, how they do it. They have like every user has a canister, but all of them are managed by the DAO. So they are able to upgrade the canisters whenever they want. Like,
Yes.
how would it work if it's only user controlled canister? And essentially, how do you upgrade, like, how do you upgrade those canisters?
Mm-hmm. Yeah, that's exactly what we are trying to do here.
Cool.
So,
Okay.
so that's it's open source also since yesterday. It's been again paused for a few months, but a lot of good things happened and a few things got solved. Anyway, I'm going to just show an example app, which it is the files here are just made with create React app. And let's see, what you have here is what I'm showing is this app, right? It has one button in here. It's the default template. What the button does is imports exec from Neutron tools and makes call to a canister with some method. The canister is our canister, and the backend of this app is here. So we have, it's a little bit different. It's not like there are some rules. It's not an actor, it's a module. And it has also a config. So what we do here is, that is how you define your functions. React hello world, right? This is getting generated. You also have to put this update here. It's a valid model, so you get syntax. But it's not made to be run. Anyway, so you do run npm run build. You can also run npm runs. The backend part won't be working, only the front end. You can just check if the thing works. So both the backend, the Motoko backend, and the React frontend, it can be any frontend, are getting compiled using our system and result this one file here. This is a binary. It has all the libraries the Motoko used extracted from mobs. Let's see. This is exactly what it has inside. These Motoko libraries, they're renamed and imports are, and there is some crunching there happening and security checks and things like that. And then they're packaged inside this binary. So So hits this and then goes like loads the binary, and then it's actually operating system. It is installing the packaged application inside. So it is going to first compile it. It runs security checks to make sure that everything is as it says it is. So that it's harder. I mean, it should be impossible to hack. But anyway, so we install the application. Yes. If there are some exceptions here, like this package is going to reinstall your kernel, or something like is going to have access to memory X of another application, or wants to code the ledger and things like that. These are shown here. And then your application is installed. It's here inside the bar. And then you click backend go. This is now part of the operating system. So the application that you install doesn't have too many permissions. You don't want, like, if you have 20 applications, you don't want them to start like stealing their funds or doing that. So there is some separation.
Okay, that's really cool. Can we see a little bit more, and can we go maybe a little bit slower on how it's done? And
okay.
So right now you have installed. So you have installed this application.
Yeah, I have installed. I think I have to, for the function to work, I think I have to refresh myself. Anyway, I think it was showing an alert here. Okay, so I'll start slower.
So who is controlling this this canister, like the one that we see on the screen?
Yep,
It's your canister, right?
I'm going to show you. I'm going to show you. So, dispenser, developers only. So it all starts from here. Yeah. We have a dispenser because somebody has to create the canister, but I think that is not that valid anymore. I think I figured it out. Yeah, I figured out later how I can install a canister directly from JavaScript, from outside code. It doesn't need a canister. So you get the, like, I'm going to sign to the dispenser. So the dispenser. And I currently have a neuron, and whoever doesn't have a neuron is going to, I don't think what, maybe they have to give half ICP or something like that for it to get started.
Okay. Yeah.
And I'm just going to click reinstall.
This is like a standard.
It is currently reinstalling my kernel. So we can see what happens with a new canister, with a new neuron. Okay, that's the first step. You're currently inside your neuron's front end.
Okay.
It's a single canister. And when you log in, it goes back to the dispenser to authorize the principal inside the new canister, because both internet identities are different, and it has to figure out who to give permissions. And now you are inside your neuron. Now you can theoretically remove the connection with the dispenser. The dispenser is only there to install your application. And from then on, your principal here, this principal, will be the controller, the only controller of this canister.
Yeah, it's just to
So
basically set up
when you are
the
installing,
kernel, right? You only need the dispenser when you set up the kernel, and then after that, it's up to the user to manage the canister, I guess, right? Ah, I think there's a sound issue, I guess. I don't hear anything anymore. Is it just me? One, two, one, two. I can't hear it either. Yeah, I think we have an issue with the sound. It just cut like still not. Yeah, I think something happened to your mic because we cannot hear anything right now. Can you hear me? Guys, can you hear me? What's happening here? Okay, let me. Info, we can't hear you at all. It's been we cannot hear anything right now. I think he probably cut the sound of his computer, I guess, so it doesn't hear us now. Because he's in I need to. We can't hear you. No, no sound. um, I will send him a DM. We can't hear you, and also we cannot hear you. The best Apple. Yeah. No, can you hear me? What about trying to leave the Zoom webinar and coming back maybe? Yeah, I'm going to share my screen. Ah, yeah, he left. I think it's better. Sorry about that, everyone. I'm guessing he will come back in a few seconds.
Okay, say something.
Yeah, it's good. It's good now.
Oh, both my keyboard and mouse stopped working, and my audio stopped working, and my microphone. I don't know how that.
What is happening here? What is
Um,
happening?
Using a Mac, things should be reliable. Let's go.
Okay, yeah, we lost you quite a few minutes ago because I was speaking, but actually you didn't hear me as well.
Yeah. Okay. So I'm going to go from installing tonight from the public repository here. So once you install it from the dispenser, which dispenser, it doesn't matter, like who owns that, because you can cut your connection to the dispenser. One of the problems with being the only controller, like your front end is being the controller of the backend, and the backend serves the front end. So if you mess things up, like if there's a faulty kernel, you lose access to all canister. So either your kernel has to deploy another canister, like a safety application, which has control over the first one. But the idea is you have control over both of them somehow. So if one canister fails, your second backup canister can fix it. Does it make sense?
Yeah, it makes sense. We don't have the screen, and I have someone at the door. I'm coming back in just 30 seconds.
Okay. It's green. So you install it from the dispenser here, and then it sends you here to your canister. And then you can install applications from this, or reinstall the whole kernel. So we don't own the kernel, we don't know anything, and anybody can make a kernel, and anybody can make apps. So we can start with a kernel like one kernel which is governed by Neutrini DAO, and it provides the basic things, and people can create their own kernels. Like some other DAO decides, oh, I want to do Neutron things, and they make their own kernel. Users are going to have to install their kernel. like this. And
Okay, yeah. And so all those applications, they would share the same canister memory, canister.
yes, so the applications are working synchronously. They don't have to work asynchronously, but this requires a lot of permissions and things to be set. What is it compiling? What's it doing? Yeah, that now if you are select the kernel. The kernel should give warnings right away. This is replacing your kernel. So everything that your module application is doing, it gets through a security check, a profile of what it's using is built, and the user has to load. Otherwise, you're just installing an app and it just replaces your whole kernel. That is next page. So this is
It brings a lot of security concerns. Like, of course, like if you have like a DeFi application and you have a NFT module that you add.
but these are handled. These are handled already. There is a config here.
How can you be sure that it's like handled 100%?
It's theoretically handled. And I mean, the whole thing is about security and control. So that's what we made. You don't see a cool interface or anything happening right now. You have Neutron JSON, which exposes different functions. All these functions that are installed, they are public functions of the canister. And you can see here in what the can't really easily see. When you, I'm going to show you the whole kernel. These are its methods. Like it can authorize, deauthorize, serve the web page, serve the operating system front end, and serve other files. Like the files, the libraries, Motoko libraries are also inside your canister, so it can compile itself. When you have, let's say you have installed 10 applications, all the packages are now inside your canister's memory. So when you add 11th application, it compiles them all when it uses the previous application sources and the new one and builds one canister.
Okay. So how would you see like what would you build like in terms of modules if you had more times? And how can we maybe do something for the bootcamp if people want to build application for this framework? How can they get started?
Yeah, it's they can get started with I don't know. I mean, they probably have to go through the Neutron repository and figure how it works. There are some example applications, but yeah, for example, this application, yeah, I think there is enough to make something basic. It's not enough to make something very complicated, like super complicated. You're defining your memory, so your application is only going to have access to your memory hello, which is anything you want. It can be B3 maps and anything, but your application has access only to that, unless it can have two applications. Like if you want to access the memory of another application, you just have to, for example, add it here. If you want to expose an async method called hello world, then you have to add it here. And this is basically how the application looks like. You write this part.
Okay.
When you want an update method, it has to be placed in comments because the syntax doesn't allow anything else. And then when you make your hello method, like for example, take input a name and output a text, these get generated so the kernel actor can then include them. So what the kernel actor is doing, let me see if I can show somewhere. Yeah, the kernel actor, this is everything compiled. I imagine all applications, all 10 applications are built into one, and that's how the file looks like. It's generated. So we have each application's memory here, stable memory. And then it's passed to each module. This is currently only the kernel, but it's an application package too. So then these are the methods we are auto-generating, which connects the actor to the model. See, these are the inputs and outputs, and it passes on whatever is required from the Neutron JSON config, and then gives the user installing it alerts if something is being used in red, green, blue, depending on security level. So, yep, somebody can start from the open source Neutron React app and build something.
Okay, that's great. I'm also in the team that we haven't explored enough the space of user-owned canisters, but it's really hard to like conceptualize how everything will work together. I mean, I have a hard time, honestly, like conceptualize how we build application in this framework, and
it is probably going to be modern in 5 years.
yeah, like it's very
because we just got DAOs, and it is going to be pretty hard to get funded when you're, I don't know, that's how I imagine it. If you're making free apps with everybody can replace you and change your kernel and stuff like that. Right? The DAOs are different. They control something small. Yeah, hopefully something small so others can join and also own something, and there can be some collaboration happening.
So what's the vision here for the? There is a DAO, right? The Neutrino DAO.
Yeah.
What is the vision for it? You've been through SNS, if I'm correct.
Yeah. Well, its vision is very long. I mean, I think someone just read the white paper to find.
Yeah, but can I get a shortcut?
I mean, we're creating a lot of things which improve the whole IC and the whole ecosystem and somehow us, and that's it. The short version.
It's like a developer tooling studio, I would say.
Just making things, and we started the DeFi working group a week ago. Okay. And hopefully other DeFi projects will come because we have a lot of great things going on there, and I'm also doing them in Motoko. I can show you like these are some ICRCs we are making right now.
Yes, yeah.
The DeFi vectors are currently what is most exciting. So, DeFi vectors are simply the simplest way to communicate between DeFi contracts, because you don't have to define standard interfaces. You just communicate through the ledger. So basically, the client canister is sending a transaction to the ledger. And then other canisters are reading from the ledger to update their state, and then writing to the ledger, and then the client gets back something. And I mean, it's about tokens, it's not about writing letters or something like that. when you send, for example, one not ICP, SNS one token to the canister, it receives alert, and then it can do something like show. It's basically one line. But visually, the idea visually is to this could be one canister, another canister, third canister, but they don't have to be canisters too. They can be just one canister can provide users with thousands of vectors, and they connect each source to another one's destination. And then when you send token to one canister, it will go to here in 30 seconds. It will go here. It will do something to move all around.
When you talk about ledger, is it a ledger in particular, or it's each ledger for each token? Like in the graph that you have, the one.
You don't have to be restrained to one ledger. It can be multiple ledgers. Depends on the vector can have a source ICP and a destination CKBTC.
Okay.
I mean, we also make that open source, but I've extracted the library from it because it can be used for many other things. Let me show you mobs. So here, DB5 ICRC ledger. It uses two other packages, which are the reader and the writer. Sender. So this is, it works. So this is how you use your library here. First, you have to do this LMEM thing to keep the memory stable, and then this is a class. So you put the ledger ID here, and then you have ledger on receive. It means the ledger receives funds, a transfer from somewhere. And if you can notice, it's not async, it's synchronous. Yeah. So you receive every transaction. It's like Express.js for ledgers. And then you can use it synchronously to send transactions. And that's it. The whole vector is one line. Cool? Yeah. Is it cool?
Yeah, it's cool. Okay, it's like a way to write transactions, and it's much more, I guess, usable as a developer. I can schedule something on receive. I would need to know how to use that and some examples, but that sounds good. Is there any like activity with the working group? I think we should be doing more like promotion to them, but it's hard.
That's one of the things we're doing in the working group.
I think that's great. Yeah.
There is explaining how it works, and also there are tests here. So currently, when you're sending, let's say you're making a DEX and you want to receive tokens, so and send tokens. Your limit currently is 500 messages maximum. You can't make more than 500, which means if you are if somebody is swapping you and you're 500 to one canister at any single time. That's how I understood it. So if you want to communicate with the ICP ledger and send transactions, this means that, and they take like 5 seconds, means you have 100 transactions per second maximum to the ICP ledger. And if you go over 100 or other things happen, like if there are not guarantee calls anymore, they can throw errors. So you have to currently check the response of your ICRC1 transfers. And if there is an error, you have to push it in a queue. and you have to do these things manually and handle the queue with timers and things like this system is completely different because it uses one-way calls, and it doesn't wait for callbacks because it reads the ledger. So it sends something and it sees, okay, in 5 seconds it was sent because it's now in transaction history. So it's cool, let me remove it from the queue, and we're not going to be trying it. But if it doesn't see it, like in 1 hour or something like that, it's going to resend the transaction. And you can use this library to set, in one update call, you cannot 30,000 transactions.
Okay.
To the queue, and it will be sending them every, like with 91 transactions a second speed if we offloading the queue, and it can read with this speed here, and it's pretty secure. We placed a ledger and a canister that uses the library and started sending, and then we stopped both canisters. We were stopping and starting and upgrading them, and it didn't miss one transaction from if you test with 20,000 transactions, which if you try to do that with something else, it's not going to happen.
Yeah, I can confirm that for having already been through the pain of integrating with like token canisters, and yeah, definitely sounds really good. So do we have the link in the, okay, we have I guess the link to the repo of the ICRC55 DeFi vector. If you want to share that with us, would be good.
Yeah. There is another vector here for splitting. Like you send an amount to it, and it splits it to 10, like 100 accounts based on something. So it doesn't have to be only exchange vector. There can be only also a scheduler vector. Let's see, I think I best share this. Okay, or just the whole working group. It has links to all of them. Vectors.
I'm sending it again because you have you have like host and panelist activated, so only me can see it right now. But I send it back. Okay, cool. That's good.
Well, and I can also show ICP coins.
Yeah.
Is the site that got us a DAO, I think. So
how many visits do you have a day on ICP coin? Around?
It depends on if there is a hype or something. I don't know. Actually, I haven't seen them per day, but I think there were 60,000 this year.
Okay, yeah. I watch it pretty regularly.
Yeah, me too. So this site uses the DeFi aggregator, which is governed by Neutronite, and it collects prices from every DEX. I mean, not every, there are others in the making, but there are 3 being used. So, and each DEX currently has a different interface. So send things like this. Sometimes the rate is in float, and sometimes it's in NAT, and there really were things going on. We had to figure everything out with the inspector and blast, and then build. We made a centralized version, and then a few months later we made the canister version, and it's now it's a single canister that currently gets you all this data comes from it.
And it's recorded inside the canister?
Yes, the canister records it.
Is it going to scale when there are more tokens, or should we be concerned at some point?
Yeah, I'm working on that. I think it can handle 2 times more tokens.
Okay. Okay, that's cool.
The problem there was a recent problem. I thought the limit was well above 1 gigabyte, but it turned out there was a limit in SNS. It's not the Motoko. That was 1 gigabyte, which they removed, and we had to. That's why we had this here. Before that, and then after that, it hasn't stopped working for a second. It was every 5 seconds. It is checking what DEXs are doing and collecting the data, and then it displays it on the site. And yeah, we have to. I think Luke is going to be making Motoko stable memory pretty great. So we have to now create standards, because currently these DEXs can change their interface. Whenever a DEX changes their interface, their line here, the prices will disappear, or they'll do something else.
Yeah.
Which is not a good idea. So we need to create standards which are also going to improve the accuracy of the data, and then we can get an audit from Solid State and other auditors. So these prices can finally be used for something more than just displaying them, like the other DeFi canisters can use them.
Yeah, that would be great. Yeah. Well, do you have something else that you want to show us? I'm super I'm super excited for everything that you've been building. I don't know how you can build so many things. Like that's
by not doing anything else but building. I don't think I had time to join many other working groups too. And I've been doing that for as long as I know myself. So it takes some time.
Yeah. I have some questions if you want from our chat.
Yep. Okay.
Let's see. So when you start a new project, how do you decide on the architecture? Do you decide before, or do you decide during the project?
I usually, the way I make my projects, I get an idea, and before the idea, I'm just browsing and checking things out, how they work, inspecting them, reading the forum. But when I get an idea, I get excited. So now I start with a sprint. I don't want to miss the wave. When I'm excited, I can work on it. And if I'm not excited, can't do anything. So it takes a 1 month sprint to create something. Most of these projects, actually all of them, are created in 1 month sprints. And then there's just maintenance and other upgrades.
Okay.
So the architecture gets decided when I get the idea. Basically, it's part of the idea. It's not like I have idea, let me create something great without having the architecture. Yeah, it makes sense.
It makes sense, especially I think on the IC, like I'm trying to make it easier for new developers to like dive into like getting into the mindset that you need to build on the IC. You need to like there are a lot of things that are hard to find. For example, what you're doing, it's hard to find, and it's important to know what other people are doing if you want to build on the IC, because it's so much about what other people are doing and how like DeFi is structured, how NFTs are structured. Not so much about the Motoko language itself. Like Motoko is pretty easy to learn, but then it's about like, okay, well, what do I build and how do I build it?
Yeah.
Yeah.
My strategy here is to create as many projects as possible and see which one gets adopted or not. For example, Blast is getting used by like 5 developers. I can't do much with it, right? ICP, NFT Anvil, the NFT hype went down when I made it. Like it was right at the end of the NFT hype globally. So it didn't get any traction. And I moved to the next project or the next project. And then I got to the ICP coins, which had traction finally. And yep, that's how I build things. If it gets traction, I focus my
Attention.
on the projects and ditch whatever doesn't have attention.
Okay. How many hours a day do you work? Also weekends?
Yeah, I mean, how many hours? I don't work a lot of hours actually. I don't know. Sometimes I can even work 4 hours. Weekends, yeah, sometimes. I only work when I'm excited. Sometimes I don't work for even months. I mean, you can check my. I mean, it doesn't look like I'm working. This is my GitHub. I'm also not uploading every single commit their private repositories, but when I'm not excited about something, I don't develop and I'm resting. There is the beach 5 minutes away. So, but when I'm excited, I use like in the zone kind of thing. I use my power to create something.
Yeah.
Then I can rest.
How many different languages work with neutrinomics?
Well, I didn't get the question.
I'm not sure. Someone is asking how many different languages work with neutrinomics, but I'm not sure. I guess with the Neutron framework that you've built, is it only for Motoko?
Neutrinomics is the foundation that works for Neutrinit. We are just setting it up now. And so we are using currently only Motoko and JavaScript. And that's it, nothing else.
Okay.
Rust is good when you go multi-chain and you need some special libraries, but this could get inside Motoko too, like we heard recently. So if that happens, we can just make everything in Motoko. And if we need a special library from Rust that's Science Ethereum cores or something like that, we can just import it and use it. I think that's planned. Not sure it's in the roadmap, but it was part of the survey.
Yeah, it was. I think it's more like longer term objective, but it's in the roadmap for Motoko, yeah, to be able to import Rust modules. Okay, great. So I think that's it. Thanks for today. If you have any question.
Thank you too. It was great.
Thanks.
Hopefully it was fun.
Yeah. Have a good day and see you next time. Thank you.
Bye-bye.